Phasors.
Okay, so today we're talking about phases. We're talking about phases. And what do we understand by phases or phase diagram? Or what are phases at all? What are the steps and the ways to draw a phasor diagram and to understand phases?
Now, phasors are used to represent sinusoidal quantities to avoid drawing the sine waves. A phasor is a straight line whose length is proportional to the RMS voltage or current it represents. To show the phase angle or phase displacement between voltages and current, phasors bears an arrow. Two phasors are said to be out of phase when they point in different direction. To be in phase means they point in the same direction. But the phase angle between them, that is when they are out of phase, the angle is too rich. One of them has to be rotated to make it to the point in the same direction.
Okay, so now from definition, there are two things you should understand here from definition. One, what do we mean by to be in phase and to be out of phase? Now, when we say to be in phase, what we simply mean is that this is a phase or a length, a phase length. And now it's always denoted by an arrow. So to be in phase, or we say two phase lengths are in phase when one, their phase angle is equal to 0. So now they are in phase when one, their phase angle is equal to 0, and two, when they point towards the same direction. When they point towards the same direction. So we say they are in phase when one, their phase angle is 0, and two, when they point towards the same direction. They are out of phase when they point towards different direction. When they point towards different direction, so now they are out of phase when they point towards different direction, and two, their phase angle is not equal to 0. The phase angle is not equal to 0. What is the phase angle? The phase angle is the angle to which when we rotate one of them to be in the same direction, the angle to which when we rotate one of them, they will be in the same direction. So this angle now becomes the phase angle. So if you understand this, one other thing you are also supposed to take note in phases is when that is between current and voltage. You should take note of these two things very well. Now, when do we mean, or how do you draw the phase diagram when it is leading? Or how do you draw the phase diagram when it is lagging? So now, for instance, when you are given that current lags voltage by, let's say, 45 degrees. When current lags voltage by 45 degrees, what it means is that when you draw your phase, voltage will be in phase, but the current will be out of phase, lagging by 45 degrees. So if this is your voltage, then your current will lag by 45 degrees. So now your 45 degrees will be equal to what? Your phase angle. Now, what do we mean when I also write current leads voltage? When current is leading voltage, let's say by 30 degrees, then the phase angle, current will be in, the voltage will be in phase, and the current will lead the voltage by a phase angle of what? 30 degrees. These are two things you should understand: the leading and the lagging phase angles. If you understand these two things, you understand everything that we'll be doing here, and even the next topic. So I want to solve one example to bring the understanding. Okay, so let's all read the question together. A
50 Hz source having RMS voltage of 240 volts delivers a RMS current of 10 ampere to a circuit. The current lags the voltage by 30 degrees. A. Draw the phasor diagram for the circuit. And B. Express the voltage and current as functions of time.
Okay, so from the question, these are the parameters we can draw out of the question. From the question, these are the parameters we can draw out. The question gave us a frequency of 50 Hz. And the question gave us RMS voltage of 240 volts. And at the same time, the question again gave us RMS current of 10 ampere. So basically, these are three things we can get from the question. And also, the question said current was lagging. Current was lagging voltage by 30 degrees. Okay. Now the first question says that how do we draw a phase diagram for this particular problem? So now, A, to draw the phase diagram, the question says that the current lags voltage by 30 degrees. So we take our voltage of V as our reference. So we take our voltage of the V as our reference. So if you take that as reference, then that one will be in phase. So now this will be our V. That is our voltage. And the question says the current was lagging. So the voltage was what? That's the VRMS 240 volts. And the question says that the current was lagging by 10 ampere. So therefore the current will be lagging by 30 degrees, and there is I, which is what? 10 ampere. But the phase angle is what? Is 30 degrees. This is equal to the phase angle. So this then becomes our phase diagram. The current is lagging the voltage by 30 degrees. Now the second question says that we express the voltage and the current as a function of time. Expressing the voltage and the current as a function of time. Now, how do we do that? Now we understand that to express the voltage or this as a function of time, then let's start with the voltage. We need our peak voltage. We need our peak voltage. So let's say our peak voltage is equal to Vm. Then what's the relation between RMS voltage and peak voltage? You realize that V RMS from previous lesson is equal to the peak voltage divided by root of 2. Okay, so if you understand this very well, then we can find our peak voltage. So peak voltage Vm will simply be equal to the V RMS root of 2. Okay, now we know V RMS, which is 240 volts, root of 2 will be our peak voltage. So therefore, to find the voltage as a function of time, it is equal to the Vm sine of 2 pi ft. This is the equation. Now we have to fix it in it. What is our frequency? Over here, our frequency was given as 50 Hz. So now, if you put frequency 50 Hz here, then we are getting our voltage as the Vm, which is 240 times root 2 sine 50 times 2 will give you 100. So times 100 by t. So therefore, our voltage as a function of time will give us this. The same way, if we want to find our current, that will also give as a function of time as the Im sine 2 pi ft. 2 pi ft. But take note that when you do this, sine 2 pi ft, it is plus a phase angle. But here, there is no phase angle because the voltage was in phase. So the phase angle for the voltage is 0. That is why we didn't bring it. But for the current, the phase angle, it was lagging. It's out of phase and it's lagging by an angle of 30. So because it's lagging, it is negative. So now, minus the phase angle. Okay. So now we find the Im. So now let's find the Im here. So the Im is simply equal to the IRMS root of 2, which is 10 root of 2. IRMS is 10 ampere. So therefore the IT simply becomes, or the current as a function of time becomes 10 root of 2 sine into bracket. Frequency is already 50 Hz. So you multiply, you get 100 phi t minus the phase angle, which is 30 degrees Celsius. And this becomes the current as a function of time. I believe you get, as you go on, we saw more examples when we have sinusoidal quantities, how we can add them and how we can subtract them. And it will really help us very well. God bless you for joining this class. Bye.